Welcome everyone to this launch of our Micro-Datathon number 3. My name is Jeff Sakave. I'm one of the organizers of Data for Good here in Calgary. And for those of you that might be new to the group, I want to give a little bit of background on Data for Good as well as our Micro-Datathons. So we're a volunteer group that uses data analytics and data science to do social good. Our aim is really to help nonprofit and social organizations get the most out of their data and to leverage their impact in the community. We're one of 9 chapters across the country, all the way from Halifax to Vancouver. In Calgary, we started in 2013. We're over 1,800 members now. And we kind of work in 3 different ways. We do these meetups traditionally on the 4th Thursday of the month. And we'll be taking a break over the summer and starting up again in September. We do larger events with larger nonprofits, datathons. We like to have them in person, and it's a Friday night, all day Saturday, and a Sunday morning. And it's a very cool event. It's very exciting. Wrangle a whole bunch of data from great organizations and come up with challenges and work with them over the course of the weekend to really get some insights on their data. But there's also a lot of smaller organizations that need some help as well. So with our Data Core Data Ambassador program, we'll often have those groups come in and talk to us at one of our meetups and about their challenges that they have. And then we'll get a team of volunteers, between 5 and 10 people typically, to work with that group. So we have a number of these projects going on right now. One with the Alberta Law Foundation, another we've just recently launched with the Canadian Cultural Mosaic Foundation. And we have 1 or 2 that are percolating right now. So we'll announce those when they're ready, and you'll have a chance to volunteer for those. So we're organized to meet up. Please share that with your friends and colleagues if they haven't signed up yet, and get them to be part of our group. You can share your experiences on our Twitter at DataForGoodYYC, and our national website is dataforgood.ca. So in Calgary, we've worked with a number of organizations. These are really the groups that we've had Datathon with over the years. And then across Canada, some of the other groups that the other chapters have worked with as well. So in fall of 2020, we hope to be having our Datathon with the Calgary Homeless Foundation. They have an amazing data set called HMIS, which is their Homelessness Management Information System. And we're one of the first groups to get permission and access to that HMIS data. And yeah, it's going to be great. We were planning to have the Datathon at the end of May. So obviously that's not going to happen, or hasn't happened. So what we did decide to do, though, was to launch this series of micro-datathons to help all of us get ready for the main datathon in the fall. So these micro-datathons are monthly challenges. So we launched them, and we have data and tools and challenges that we put before you when we launch. You've been provided with the instruction sheet, which has a huge amount of information that takes you through how to connect with all of that. And then over the course of the month, we'll hope you'll tackle some of those challenges, and more importantly, share your results and your insights as we go through the month. So micro number 1 was around geospatial data analysis on April 23rd. And so we had data and shapefiles and challenges all around using geospatial data. But if you missed that and you still want to see what was done, if you go back to the April 23rd meetup, the past event on our meetup site, you'll see the links to the recordings, to the instruction sheet, to videos, all kinds of really good stuff. So you can actually still go through that and go through those challenges. Micro number 2 was around exploring census data. The date of that was May 28th, and same story. You can get all those links if you go to that past event. And there we were exploring the latest 2016 census data and how some of that related to homelessness as well. So this evening we're launching micro number 3, all about data wrangling, quality, and reproducibility. And here's what we'll be doing this evening. So this is my part at the beginning. Then we'll have Henna, who will come on and give us a presentation with some great information around data quality. And then we'll give us a demo of a really great tool that's an open source tool, readily available, can be very helpful for wrangling and looking at data. So Open Refine is that tool. Then we'll have Corrine, who will give us an overview of the data sets that we've collected for this Micro-Datathon. And we have a bunch, and there's some really good stuff. We actually have an extract from HMIS with some real data around some of the agencies and programs. So that's really cool, and you'll be able to see that and use that and help us organize that and improve the quality of that information. And then Corinne will review challenges. And we set up the challenges at sort of 3 levels, a basic, intermediate, and advanced level. And Corinne will take a quick pass through that. And then finally, Henna will come back and really talk about how to access the data using data.world and how to kind of submit your results and communicate through data.world, but also through our Slack, our Data for Good Alberta Slack setup. Yeah, and then a quick wrap up, and then all will be done. So I'm going to stop sharing now, and I'll hand it over to Henna. Take it away, Henna, for your portions.
Okay, hi everyone. I'm Henna. I guess I'll start with the presentation first and then explain.
So talk as loud as you can, Henna, so we can hear you clearly then.
Okay, all right. I'll try my best. Okay, hi everyone. I'm Henna, and I'm a bioinformatician at the University of Calgary. I'm also part of the Data for Good core team. And at my job as a bioinformatician, the best part of my job is actually to help researchers and scientists make sense of their data. And I would say the worst part of my job is when I have to tell people that their data doesn't make sense, and we cannot do much with it. So today, I would like to talk about some of the steps that everyone should kind of do before performing any analysis. So basically things like data profiling, data cleaning, checking the quality, etc. And another important part that I would like to focus on today is how do you perform all these operations, but perform them with adding reproducibility to them, okay? Because that's important. You want other people to be able to kind of reproduce whatever you have done and replicate it. Okay, so let's start this talk. And these slides are some effort from me and the rest from Corinne and Paula. And Paula couldn't join today, so that's why I'm presenting this. Okay, so I want to start with, okay, let's see if I can move. Oh, okay, move the slides. All right, so I want to start with this concept that we have in computer science and now in data science, that you know, garbage in, garbage out, meaning that if you have nonsense input data, no matter how awesome your kind of algorithms or data analysis methods are, you're going to end up with garbage or nonsense results. So, you know, like if you as a data analyst or a data scientist, if you don't pay attention to the data's quality, its completeness, or don't make an effort to clean that data, you know, you would probably end up with kind of conclusions from that analysis that are kind of bad or unusable, or can, you know, result in misleading decisions. So so like at that point, there aren't much algorithms that will help you salvage that analysis. So I would like to emphasize that, you know, people should spend time on all the kind of steps of a data analysis or data pipeline. So what I'm going to share with you now is what I think are the steps that people should take. And, you know, if you talk to different people, they'll have some more or some different order of this. So this is what I think is a data kind of cycle or the path to your data analysis. So the first and the most important step is data collection. Sometimes, you know, if you're doing an analysis for someone else, they might have already collected the data for you, and they'll have, you know, they'll give you the data and have a bunch of questions that they want you to answer. Or on other occasions, you'll have people who come to you and, you know, with a question, and then they ask you to find a relative, like not relative, but data sets that could help them answer that question. So once you have in either case you end up with a data set or a bunch of data sets. So in that case, the next step is what we call data profiling, or understanding the data. So then you want to understand this data. Basically, there are tables. You want to know what columns are, you know, what are the kind of values in there, and, you know, like just to understand each of those tables or files that you end up with. So once you have an idea about your data, you have an understanding, then we go to data cleansing or cleaning, or check the quality of the data. So this is a very important step. This is where you kind of deduplicate things. If you have, you know, something occurring more than once, you put some thresholds to kind of, you know, say that the value should be between this range, and or you also, you know, figure out what to do with your missing values or how many are missing. So the next step is transforming the data, or sometimes it's called data wrangling. It's part of data wrangling. And this step can occur before cleaning or after. It depends on what you prefer. And in that step, what you do is, if you've collected, you know, different data sets, what you do is you take all that somewhat raw data and convert it into a format that would be useful or meaningful for your particular analysis. And then if you've done all those steps, that's when you start doing your actual, you know, analysis or visualization. And this is also, these steps are also important because if the data is not good, you know ahead of time, and you don't waste your time trying to, you know, do the analysis. So where do we start? We start, the most important thing when you're doing this kind of analysis is figuring out what is the context. Okay, like you must have an idea what, you know, what is the question that you're trying to answer, what is the data that you've collected really about, because you can use the same data set to answer different questions, right? You can do the same, give the same data set to 10 people, and most probably you'll get, you know, 5 different kinds of analysis. So context is really important. And who gives you context are either your clients, your colleagues, or whoever has, you know, has come up with the question for you. So it's the clients, I'm going to call them clients here, but they can be anyone asking you for help. So the important part there is to understand, what is their problem, or what are the questions that they're trying to answer. And then very important is the fact that when you have a discussion with them, you can in the end come up with a set of questions that you think they want to answer, right? And you can kind of keep referring to them when you're doing your analysis or at any of these steps, or if you have to collect data, to make sure that the data that you've collected is meaningful for those for answering those questions. And then in terms of context, it also helps you to know what level of data is required, how much kind of granularity you need, how much detail you need. So be conservative in the sense that try to find the correct level of data. You don't want to have too much data for a simpler question. But if you end up with a lot of data and you have already answered those questions, and then you have some more queries, you can go ahead and dig deep into it. An important point is getting to know your data, like I said before, and try and make your data set easier to work with. So if you have too many files or unnecessary information, take it out. If you're a person who's better looking at kind of longitudinal data, then change when you're doing this transformation, change your data into that format. So kind of make it easier in the sense that change it into a format that works for you. And then a very important point here is that when you're working with data, you definitely, the most important part is you need technical skills, but equally important are your soft skills. So by soft skills, I mean, your ability to communicate with people, because here you're interacting with people. You have to listen to them, you have to understand what they're saying. And at the same time, once you have done the analysis for them, you have to explain things to them. So your ability to communicate is important. Being very clear about whatever you found, being honest in the situation, and also sometimes having this ability to make decisions. So because the client or the who have come to you might not be able to make critical decisions, and they might rely on you for that. So technical skills, yes, are important, but at the same time, these soft skills are very important too. So once you have collected your data, you kind of know a little bit about it. The next step is looking at the quality of the data and cleaning it. So in a perfect world, all data would have really good quality, but that's not the case. You rarely ever find data that is really good quality. So to kind of assess, right, that how good is this data, you can set up some kind of metrics that help you with that. And what it does, it helps you kind of develop more trust in your data, and then later on give you more confidence in the results that you have. And here are just 6 such kind of dimensions or metrics that you can measure. You can look at the completeness of data. Is it filled 100% or 90 or 80? That's always good to know, because we're going to make assumptions about that missing data most probably at some time in our analysis. So it's good to know that how much of the data is actually not there. So uniqueness is important, because if you have kind of are the same things repeated again? Are there variables that are correlated? Sometimes people measure one thing, and then, for example, weight, you can have it in kilograms and then in grams. So that's not, it's the same thing. So that's gives you an idea of uniqueness of the data. You should check if it's consistent. Is it accurate? Accurate meaning is it accurate in the sense of real world expectations, what we expect, and timeliness in the sense that if it's data that is over some time, is it kind of representing what you want? So these are some of the things you can keep in mind when you're doing data cleaning or quality. Then comes, once you're done with that, comes a part of transforming and mapping your data. As I said before, this is part of data wrangling. And that's where you change your data from one format to another format, which is more appropriate for your analysis. Again, transparency and clarity is very, very crucial. You need to be honest, open. A lot of the times in my experience, not a lot, but okay, maybe 30% of the times it happens that the data is not good enough. For example, in biological data, people measure, let's say you do some experiment with human samples and you don't have enough sample size, but you have some data and you want to get some statistics out of it. So in that case, you have to be honest and open and say that, no, this is not enough. You need more samples, or you need more information for me to make some sense of this data. Another thing is very important skill, and if you have that, very valuable skill is learning how to do good visualization techniques, right? So for that, you can go ahead and look in Google, and if you do bad charts, it gives you beautiful examples of meaningless and bad charts. So that's a good way to start, where you see, okay, this is what I should not do. And then here's a link to a book, ebook about design, how to kind of make your visualizations better. So if you have time, take a look at that. And I'm going to now give you examples of some things that kind of I find that people should not do when they're doing visualizations. One of them is, the first one is like having unnecessary graphs. So if you have done some analysis and something is very obvious, don't make a plot about it. Just like you can just write a line about it. There's no point in making a plot that does not give you any extra information. Don't have too much information in a plot. If you have, like in this particular plot on the right side, top right, there's too much information here, and it's hard for people to kind of comprehend it quickly. And last, and my most favorite, is choosing bad chart types. This is very common. Finding what is an appropriate chart type to represent is very, very important. In my opinion, there is never a need for using a pie chart. You can always show the data much better in using any other chart, not any, but other chart types than actually a pie chart. So it's in my opinion one of the worst ways of showing data. But if you have to, because sometimes people ask you for it, then you have to make them, but try to avoid them if you can. And other reasons why your visualization might not be good, it could be you had either incomplete data, or you're trying to force some conclusions, or sometimes people are comparing apples to oranges. They don't, doesn't make sense. And it could be unreliable data. A lot of the times the chart axes are either, they are manipulated, meaning that they don't start from 0. They sometimes start from 50. Sometimes, like they can be stretched to make your data look better. So be careful about these things. And this is another, I think Paula added this slide, and this is a great presentation on how charts can lie. And Alberto Caro has done a great job at making a set of slides for New York Times, where he's showing how these maps for showing when hurricanes come can be actually misleading for people. So it's a really interesting set of slides. Like if you have time, take a look at it. And also when you start doing your analysis, you have an idea, you have a direction of where you're going, but a lot of the times you recognize that you get answers to questions that you didn't have. So you get some extra information from your data, and sometimes, and it happens a lot, I think, at least in the area that I work with, that sometimes your answers lead to new questions. And this happens when, you know, somebody came to you and said, hey, can you look at this data? I have this hypothesis. Can you see if it works? Can you validate it? And then if you go do the analysis, and sometimes either it gives you, it cannot be validated, or there is another reason that pops up. And then comes more questions that you have to go and then answer. So, I mean, you have an idea, but it sometimes leads to very interesting findings. Okay, so far I've covered all the steps I think people should keep in mind when they're doing their analysis. Or in the start of the presentation, I said, you know, it's important to make sure that your data is reproducible, and that's important because if you're in research and you're publishing something, you want to make sure, especially if it's a new finding, important finding, you want to make sure that if somebody wants to go ahead and look at your data, if you have collected the data and process it, that they can actually replicate it. Also, you know, I'm sure most of you have experienced this, that we open a file, some data that we've gotten, we open a file in Excel. You know, the first thing we do is start changing the name of the columns, or I do that. Then you look at the values, maybe you know, change something to log, you might delete some columns, you might add something. And in the end, you know, if you're making a plot, you make a plot. If you're gonna, if that's your input file into your analysis pipeline, then you do that. But, you know, comes a month later, you're looking at that file again, and at least most of the time, I have no idea how I got there. And I can figure out like 60% of it, but the rest 40%, I have no idea what I did. So for that reason, it's very important to document what you're doing. So every step of your kind of pipeline should be documented. So there are different ways of documenting. So if you have, I'm sure a lot of you do that, for your pipeline, for the analysis part, we usually have, you know, either we use Jupyter notebooks or our Markdown files or our notebooks to keep a record of everything that we have done. It makes code sharing easy also. But when it comes to data cleaning, in my experience, a lot of people don't document what steps they're doing. There are very, very few people who actually do that. And what happens is, if you're working in a lab, you know, people move, so they leave the lab, and then the new people are sitting there wondering what were the steps that they're taking. So it's important for any organization or any facility to make sure that they document all the steps. And to make it easy for the data wrangling or cleaning part, there are a bunch of tools available now that you can use. And some of them are free. So you can use Power BI, you can use Trifacta, there's OpenRefine. Excel also has some advanced features where you can do that. I am today going to demo one of these tools, which is OpenRefine. And OpenRefine is used for, you know, cleaning your data or transforming it. It's an open source software. It's free. It's a powerful tool, and this could be a first step, if not, you know, first step to give you some idea about your data. Some, you know, you can do some kind of an exploratory analysis there. So OpenRefine is secure, so you can download it from their website, and it's local on your machine. It opens up in your browser, but still they don't have access to your data, and it's not on a cloud or anywhere. You can save recipes. So by recipe, I mean the documentation of what steps you have taken. So it automatically saves all the steps that you have done, and you can basically save that and then reuse it for another data set if it has, you know, if it's just a kind of a timestamped data set of the same an older data set that you were using. So you can use the same recipe. Unless you do batch processing. So you can, if you have a bunch of files, like if some data was collected every month for a few years, and all the columns are the same, you can just use their batch processing. They have extensions, meaning that you can access it through R, Python, Ruby, etc. So all the other languages you can kind of connect to OpenRefine. It has some kind of a reconciliation function where you can connect to big databases also and kind of compare what you have. And it also has API processing plugin. So I am going to show you guys. So I'm going to give you a demo now of OpenRefine. Okay. So if you download OpenRefine and you click on it, basically opens up in your browser, and then you can you get this kind of an interface here. Let me get a pointer just to. You can't get a pointer here, but all right. Okay, so here, this is the basic interface that you'll get. On the left side, it has a tab for create a project. You can open your old projects if you have any. You can import a project if somebody else has sent you an OpenRefine project. On here, you can choose a file. So for example, I'm going to choose one metadata file, clinical file that I have here as an example. So you can click open and then press next. It's going to upload your data. It's going to give you a view of your data so that you can have an idea if the data looks okay or not. So to me, this looks okay. Otherwise, down here, you can change it to tab or commas and see if it's not looking good. And you can have some custom options here if your file is really special. Otherwise, if everything is fine, you can go and check the name of your project name. You can change it to whatever you want. You can add tags if you're going to have a lot of projects to help you search. Otherwise, you can go and say create project. So then it's going to go upload your data. Okay, and then it's going to open your project. So if you look here, this is again our the CSV file that I uploaded. All the columns are here. It's telling me that it has 99 rows on the left. It has this face it filter tab here, and then it's do or undo tab here. I'll show you in a second what these tabs are. So when you read in your data, everything is read in here as text. So if you have a column that has numbers, like I have age collection here, I can go click on this little upside down triangle, and then I can just go to edit cell. I can say transform this, go to common transforms, and then I can say make it to a number. So when you click this, you see these become all green because they're numbers now, and you get this message up here saying that we have transformed 78 cells in column age collection, and it gives you a chance to undo things here. So on the left side, this undo and redo panel right here, this is where it's saving every command that you have done. So it has it's going to have all populate this tab with all the commands that we're going to use. So let's say now I'm looking at these ages, and I don't want ages to be in decimals. So I can go back again. I can do edit cells. Sorry, edit. Oh, sorry, it's still edit cells, but you can say transform this data, and then it opens up this window where you can kind of use add expressions. So OpenRefine has a built-in its own language, which is called the General Refine Expression Language. And here you can write kind of like it has some built-in functions that you can use. And here you can look on the help tab. And if you go down, you can see all the functions that you can use here. Okay. So let's go back to our preview. You can see the row, all the values are here. And then on the right side, it's empty right now, but it will tell you what the how it has changed this number. So let's say I want to round them. So I can say that round this column, and you can see here now the numbers, these numbers have changed and they're integers now. So let's say this is what I want to do. I can hit OK, and then my column is changed. Okay? And then it gives you an option if you want to undo it, you can do it from here. Also, if I want to undo, I can go back and click on the left side in this undo redo button, tab, and then I can click it that I don't want that. And you can see if I go to number 1, it makes them again numeric, and it has decimal places. So then you can go to 2, and then you see the data as it is after that transformation. Okay, let's look at some interesting things, which are in this case facets, another feature. So let's say, for example, in the smoking status here, I don't want to, I want to remove all the smoker from these values. So I only want to keep never or former. I don't care about smoker. So in this case, I can go and say edit column, and I can say edit column based on this column. Okay, and then you can give a name of the new column. Let's say let's get smoking, and then here you can use another function called replace. Okay. And then in here you can say replace. I want to replace smoker with nothing. Okay, and then you can see if the value is null, it's saying it's an error. I cannot do this. But otherwise, it has removed smoker from here, and all you have is never or former. Then you can hit OK, and it's going to make a new column here, which is smoking. I don't need this column, so I can go to edit columns again. Okay, and then I can say remove this column, and it will remove the column. Another cool feature here is for genders. That makes, I think, OpenDefine very powerful. As a facet, so you can say this is text, so give me a facet text, and then on this left side of this facet tab, you can see that it has written that gender has 7 possible choices in this whole column, and it's sorting it by name. You can also sort it by count. So male has 38 counts, and females have 33, and then these the rest of them have 1 or 2. So this happens quite often when there's a form or something that people have filled, and there's data that somebody has hand filled. So you can see that this female is 33, and this female has a white space in front of it. That's why there are three cells that have this value. It has been misspelled. It has also a lowercase, something similar with the male. So instead of going in, and I can do this, I can go into any column that I see is wrong and edit it. So for example, I want to capitalize this. I can edit it, and then here I can make it capital, and then I can apply changes here. But an easier way is you can press this cluster button here, and then what it does is it opens another tab, and it says cluster and edit the column gender. So here, this basically helps you to figure out things that have been lowercase or uppercase, or some name that has been changed, like there's one letter that is misspelled, stuff like that. And this clustering has two methods. Either you can use key collision or nearest neighbor. If you want to read more about it, I have a link in the PowerPoint to their GitHub page where they have a detailed explanation. And then each method has a keying function. So from here, you can try different ones. So this is the first one, and I can see that from my 7 choices, I only have 5 here. So I can try another method to see if that can capture the level of detail that I need. And now I have, you can see the cluster size 4 and 3. And it's saying that there are 41 counts, and it's showing you each how many rows have this value. If you want to merge them, if they make sense, because they're all female here, so I can say yes, merge it, and name them female. You can change it to whatever you want. And then similarly for males, I can say yes, merge it, and then it will merge everything and call it, and it'll merge all the males and then call all these rows male. So you can say merge, selected and close. And then if we look at, let's make it bigger. If you look at all the rows, it's hard to see from here. So you can go to the left side again, look at this facet, and it says, now we have basically two choices, female and male, right? And then we have 18 blanks. So it's giving you all this information. If you want to remove the blanks, you can go here and you can say exclude the blanks. So it will, exclude it from our data set. So this is a little bit about faceting. I also wanted to show you that you can merge multiple columns. So like, for example, here, I have multiple columns for medication. I think there are 8 or 9 of these. So there's information about, they got medication that maybe the first time they got, this particular drug, the second time they got this. But let's say I just don't care about the order. I just want to join this information. So in that case, I can again click on this little button, go to edit column, and this time I want to join columns. Okay, so and this opens up another window, and you can see that say select and order columns to join. So the first one is medication one, which I selected, and then I can select all the other ones that I want to merge with it. And then on the right side, it has some options. So you can select the operator that you want to be between the contents of each column. And let's say I want to have a pipe in between them. Then it's asking, okay, if I end up with null characters, what do you want me to do? In this case, I don't care. I want to skip them. And then you can choose if you want a separator. In separator null substitutes, you want to use this or that. You could say check it or not, and then it's going to ask you if you want to write the results in a new column. You can go here, and then you can give it a new name. Let's say I just want to call it medication instead of medication 1, 2, 3. And then it's asking you if you want to delete the join column. So all the columns here that we use for joining, it's just asking if you want to delete them. And let's say I want to delete them. I can check this box and say okay. And then it's going to delete all those boxes. And you can see here, I only have one column now, medication. All the medications are in here. And this, you can see the pipe here that's separating from medication 1 to 2 to 3. So this is what you can do. If you want to split it again, that's also easy. You can just go to edit column, and it says split into several columns. And again, we have the pipe separator. You can put it here, and then you can hit OK. And again, you have all those columns back because it's been split. Other things that you can do is, for example, if you have one value, you want to convert it, because we do a lot of log transforms. So you can say transform, and there's a function called .log, and it changes them to log. I mean, you don't want to do ages in logs usually, but just in case you have another value, you can use this. Instead of using this generative-defined expression language, you can also use Python, and that will, I mean, if you're more familiar with Python, you can use that, or you can learn, and this is very similar to JavaScript, you can learn generative-defined expression language also. Let's okay this, and these values are again in, they're in log. Okay, so what if I said before, if you want to undo something redo, now you see this list has populated, and you can, you can just go back to wherever you want, and it'll kind of revert to that level. So if I do this, everything is changed back. I can go down again and say, okay, no, I want to be in this log transform, and I want all these columns to be separated. So if this is my final copy, okay, I hit the wrong button. So if this is my final copy, and I want to save it from here, you can see using this extract button, you can extract all the kind of transformations or data cleaning that you've done, and it becomes a JSON file that you should copy, and then you can paste it into any text file. And then save this because that's your recipe. Okay, so this is what you can share with your colleagues, or if there are 5 people working on a project in a group, this is very useful, and you can share this with others. And especially if you are going to work with this on our Micro-Datathon, then we would really appreciate if you can copy and paste these into a text file and send it to us. Okay, and the last thing is you can export this whole as a project, or if you want a comma separated value, you can do that. And if it has some templates also and some kind of extensions and reconciliation, then you can, if it was something you were editing from Wikidata, you can upload it back there. Otherwise, if you just want to save it as a comma separated file, you can just go ahead and save this, rename the file as you want, and it'll be saved. Okay, that was all that I wanted to say about OpenRefine. And let's go to presentation mode again. So I've added a bunch of links. There are a lot of really good courses from Library Carpentry that you can take, and they're at a beginner level or intermediate level, and you can learn really well how to work with OpenRefine. Okay, and there's a wiki page on their GitHub page. There's a wiki page which has all the possible details that you need. If you're interested in reading about clustering, it's also up there. Or if you want to learn more about their expression language, all the information and all the functions are there. I've added some, actually these are not my slides, Paula made them, but about how you can do basic things in Excel. Remember that if you're using Excel, open a document on with it and start kind of taking notes of what you're changing or filtering or doing stuff with it. This is again how you can do data profile in Excel. This is some advanced level stuff here, and I'll leave this slide for you guys to look at. There's some links for Trifacta. Again, most of these tools are free for personal use. They're not free if you are, if it's for a company, you'll have to get their license. But otherwise, for personal use, they are free. There are some examples on, how do you use OpenRefine, or there's also Paula's blog on, how to use it with Excel or Trifacta. In the end, I just want to say that, if you want to learn how to do these things, you can find data sets in Kaggle and in many other places. So take a data set and start playing with it, right? So just understand it first before you start using any cool methods. Machine learning is really hot, or AI is really hot, but before you start using AI or machine learning on the data, spend some time understanding it. Spend some time, just getting to know it. Just play with it for an hour or so, and that would really help you in understanding what the results are in the end. There are more sites that you can go to. In summary, I just want to say that we all learn from trying. So find a data set that you want to play with. Calgary City has its own open Calgary data. It's really interesting stuff in there. And I've downloaded some data from there too, just to play with. And one interesting one is actually it has a huge data set. I think it's 1 or 2 GB, which is all about property taxes. So you can find out property taxes for every place in Calgary for I think it's for the past 10 years or something. So that could be cool to kind of assess what are the kind of property values in different areas, or so I found it very interesting to just play with it. Yeah, so spend some time understanding the data set. Develop both technical and soft skills. Be honest, and it's hard to do sometimes when you have to tell someone, hey, we did the analysis and there's nothing in there, or there's no signal. It's hard to do, but you have to learn to do it, because otherwise it'll be really hard for you to function in this field, because it is like kind of a reality. It happens often. And always use tools that can help you make your pipelines or reproducible. I think that's about it from me. I'm going to stop sharing my screen, and if there are any questions, feel free to ask.
Yeah, I think Hannah, I think it's difficult to ask questions in this type of setting. I mean, that was a really excellent presentation. So your deck you'll make available, right?
Yes.
Like, you send me a copy of it, and I will post it. I would encourage, though, people to give all this stuff a try, and then if you have questions, then use our Slack, our Micro-Datathon Slack channel to actually share your questions, and Hannah and Corrine and Paula will answer them. But the advantage of using Slack is that other people can see it as well. So we get a lot of good collaboration and sharing of questions and answers. So it works really well. Yeah,
sorry, I forgot to go over that. So in the document that we have shared, the instructions document, there's a section about how to access data. And all our data is on data.world. So you need to make an account. And then once you're on that page, you can just search for us, Data for Good, and you'll find the data set, and the links are right here in this document also. And for sharing your results and your recipes, if you just want to share some findings inside the project, and just go to Data for Good. If you go here, this is our micro-datathon number 3, and you can add insights. It says new insights here, so you can add insights here, and just add your results.
Sorry, Hannah, I'm seeing a please complete your email registration. So I don't think we're seeing what you're trying to show us.
Oh yeah, sorry. Sorry, just one second, guys.
Do you want to do this section at the end after Corrine?
Oh yeah, sure.
Okay. All right. So thanks so much, Hannah. That was just great. Corrine, you're up for your portions.
Okay, thank you. I'll just share my screen, and let's see. So can you see my screen?
Yeah, it looks good.
Okay. So I'm going to be talking about the data we have, and it's a smaller data set this time because the emphasis is on data cleaning rather than understanding a broader scope of data. So the data we'll be showing you are different sources of organization names. They could be agencies, they could be shelters, they could be other organizations that support moving away from homelessness, helping people get settled in a stable home life. And doing that, we've got the names of organizations, we have domain lists or pick lists about the organizations, and we have addresses. So I'd like to just flip over to data.world for a moment. And this is the link to our Micro-Datathon number 3, data quality. So when you're in data.world, our links that we've given you will take you to this site where you can read about the project we've set up, or you can go straight to launching the workspace. And coincidentally, there you can also read about what this project is about. And you can get a data dictionary of the data sets we have. And then we've provided a number of data sets for you to work with. You'll see here under project summary, we've made a list of the data sets. So for each data set, starting with the data set specific to this Micro-Datathon, And that is the list of agencies and programs that we received from the Calgary Homeless Foundation. So there's a number of columns. The three that we'll have you look at this month are the agency name, the program name, and the program type. Because agency names will be linkable to a number of other organizations. And program name may be linkable to organizations because some shelters are set up as an organization in their own right. And then the program type would tell you, like, is this an emergency shelter? Is it transitional housing, etc. So next data set is the first one that we introduced you to in April, getting to know geospatial. And one of the key files or tables we had was an organization table that Paula Jennings built based on Google Place keywords and organizations she found in Calgary Foundation. So this is another list of organizations. It's our starting point for our set of organizations, and we want to extend that with data from the Calgary Homeless Foundation and other organizations, and start to build a clean list of organizations that we can reuse year after year. Then we skip ahead to exploring homelessness focus on Calgary. And we have an open data set from Alberta Open Data, and this emergency shelter occupancy. So here you'll see, again, a number of shelters that you can tie into the organizations we've already talked about. And finally, our last data set is Calgary Charities List. And this charities list was built from the Canadian charitable donation recipients and from Alberta grant recipients. So you'll see more organizations in these two lists. You'll see more pick lists or domain lists that come with each, with the Canadian charity and with the Alberta grants. So you can use this project summary to help you understand what's in these data sets and what's relevant to this micro-datathon. The data dictionary will give you more detail on some of the data sets, and particularly the one from the Calgary Homeless Foundation. So now that we've given you a whole bunch of data, we would like to assign you some challenges. Of course, you're welcome to use OpenRefine or the other tools to do whatever you would like, because you may have your own data sets you'd like to clean. But if you don't have your own data set, or if you'd like to start practicing on a different data set to expand your horizons, we invite you to work on these data sets, because the work you do could help us have a cleaner data set going into the fall datathon. And the cleaner the data, the easier it is to work with and the better the results. Like you saw on Henna's first slide, and intuitively, if not by experience, we all understand that. So back to our presentation. What I'm showing you now are the challenges, and these challenges you will find on data.world as well in the instruction sheet, or you will see it in the information that Jeff sent out. You'll see it in the Meetup group. These instructions have the list of challenges, and they tell you where to find the data to do those challenges. So I'll just wait until I can get back to the presentation. So our basic challenge is to take the list of agencies that the Calgary Homeless Foundation gave us and align them with Data for Goods organizations. And this isn't too tough, because there's only about 30 agencies in the CHF list. There's about 450 in Data for Good. So you could do this manually using Excel, for example. And like Henna said, try to remember to write down your steps. It's a really good habit to get into, not just for other people, but for yourself. Because sometimes you go back and you're thinking, what was I thinking? And when you've written it down, it saves you so much time after the fact. So when you're aligning the programs in the way CHF named them and the programs in the way that we named them, based on what they were called in Google Places or what they're called by the Calgary Foundation, we need to align, to merge. So we need to choose the best name. And for now, you can choose the best name however you see fit, just intuitively, or you can visit the organization's website to see what they would like to call themselves. Depends on how much work you want to put into this exercise, which is a lot of what data quality cleanup is about. And then build a cross-reference. So when you build this list of the best names, build references to the original list in CHF agency and the original list from Data4Good organization, so that we know for each organization that you propose as the cleanest list, how it links to the other lists. I've added a section at the end of the instructions document with some tips to help you get started if you would like to look at the tips, or you can dive right in. Now, once you've done exercise 1, the first basic exercise, then you can just repeat the exercise using the Calgary Homeless Foundation's program names, because a number of their programs, especially when they're emergency shelters, do relate to other organizations. Brenda's Cottage would be an example of that. Second, you can take Calgary Homeless Foundation's agencies and link them to the Alberta Open Data list of emergency shelter occupancy, because doing this lets us now start to join all these different data sets together in ways that we couldn't before, because if the names of the organizations are just slightly different, the computers aren't going to put that together. We need to build that single list and then all the cross-references so that we can then link Calgary Homeless Foundation's information with the emergency shelter occupancy to compare results. So step 4 is you did it with the agencies, now do it with the programs, like Brenda's Cottage, to see if Brenda's Cottage is found in the emergency shelter occupancy and come up with a list that links it. So that's your basic challenges. You're just working with organizations, you're cleaning up the list, you're figuring out what different names are the same, or maybe it's different. Because sometimes similar, it does not mean the same. You have to be thinking and investigating as you do this. Next is our intermediate challenges. So what you get to do now is take Calgary Homeless Foundation's list of agencies and programs and merge it with Alberta grants. Now, Alberta grants are organizations that received grants from the Alberta government. It's a big list, so it's tougher to make this connection. But if you can make this connection, then we start to see funding that's going into these organizations. Likewise, if you link these agencies and programs with the Canadian charity donees, i.e. organizations that received money via charity, that's another rich name. So this is the same as what you did with the basic challenges, except the list is so much bigger that it makes life more difficult, more interesting, more challenging. And again, if people can put this together, it gives us a better data set. New challenge at the intermediate level is to look at our domains or pick lists. And pick lists in general are often flawed because they may be mixing several concepts together. And we have seen this, like when you combine, some pick lists combine gender and age, or they combine multiple concepts into the same pick list, and they make it difficult to work with. Second, you might find a pick list that has gaps. So you find that you've got a number of organizations and the values in the pick list won't cover all the situations you encounter. Or worse yet, you find they're overlapping. So sometimes you'll find 2 values that will match the same organization, for example, and that's a problem. So if you're designing a pick list, you try to keep it clean. So each pick list addresses one concept, it's complete, and it does not overlap. Finally, and keeping this in mind, we would like you to look at a bunch of pick lists, domain lists that we have come across from Canadian, from Government of Canada, Government of Alberta, Calgary Homeless Foundation, Calgary Foundation, and Google Places. And we want to see if you can come up with a clean set of pick lists to describe these organizations. And then, if possible, start to cross-reference different pick lists that we have to say, you know, we called it X in this list of values, and it's called Y in this list of values, but they cover the same situation, or they're almost the same, because that may help us with the work we do in the fall. So here you see the list of values, and you can see these are all hyperlinks. So when you look at the instruction document, it will make it easy for you to find these domain lists. Next challenge is addresses. And we love addresses because they give us access to geospatial information. But when we work with data sets, we often find addresses are incomplete. Like some of the addresses in our organization list just say Edmonton Trail, which is really vague. It doesn't give us enough information. There's a chance that the information isn't even accurate. So we've seen addresses on the Centre Street Bridge, and we're pretty sure there's no organization on the Centre Street Bridge. So some organization has chosen that as probably a we don't know kind of value. But if you don't recognize that, it's going to skew your results. And finally, a lot of groups don't think about this, but it's helpful to know what kind of address you're working with. Are you working with a mailing address or a billing address, which is not irrelevant, or a head office may be useful, but if it's a functional site, that's really useful. So if we're looking at emergency shelters, it's more interesting to know where the shelter is located, so where people are finding help, versus the billing address or the mailing address or the head office. So we'd like to see our addresses tagged to see what kind of address it is. So if you're willing to take this on, the Data for Good organization list has a number of addresses that you can check for completeness, accuracy, add or identify the address type, and add a column to indicate your confidence on how clean that address is. Because if we know what the high quality addresses are, then we can focus our attention on the low quality addresses. If you've done that and you want more, you can look at this Calgary Homeless Foundation's agency list, which they provided without addresses. So this is a chance for you to go to the internet or other sources and add addresses and see if you can make complete addresses, accurate addresses, identify the address type, and indicate the confidence. With that kind of information, that allows us to invoke geospatial, and people love maps. Maps can be very helpful and useful when you're doing data analysis. So if you've done all that and you're still having fun, then we'd like to introduce you to the advanced challenges. And the first advanced challenge is the Data for Good organization. So we had you start with the Calgary Homeless Foundation's list of agencies. And these are primarily agencies they fund directly or agencies that are using their HMIS system. So it's a smaller list than all the organizations in Calgary. So Paula created a starting list of organizations with 470 organizations. And if you like, you can take this list and start to do the cleanup. And a bigger list means bigger challenges. You may need to change your approach. So this gives you a chance to start to scale up your data quality work. With the addresses, we have an interesting problem, and we'd like to see what solutions you guys would like to propose. And if you like, you can jump straight to this challenge, because this is a bit of a different challenge. This challenge is around addresses that are confidential, like the Women's Emergency Shelter. The address is not published because they want to maintain the security and safety of their clients. For us, this is a problem if we do not have access to their actual address, because we have to decide how to represent that in our data set. Like whether we give it an address on the Centre Street Bridge, whether we tag it as an unknown address, or do we put it outside Calgary? Do we just filter those rows out? There's a number of choices you can make in how to deal with this. And it's good for you to think about how you deal with difficult data that you would like to make conform, but you can't for one reason or another. And come up with one or more solutions and talk about the pros or cons of the solution to show, if you understand what the impacts are, that helps you pick the right solution when you deal with this kind of an issue, which you can then bring back to your own workplace, your own challenges. After that, we just say, go wild. Look at other data for good data sets to see if you can find data quality problems. Try to produce a cleaner data set. We have a number of Statistics Canada data sets and a number of geospatial data sets that we would be happy for you to look at. So that is the gamut of our challenges. And I'm going to turn the stage back to Henna, and she will tell you how you can report the findings from your challenges, show people what you've been doing, and show us and share with us what you've been doing.
Thanks, Corinne. That's a nice comprehensive overview of the data as well as the challenges. So an awful lot there. So we'll hope that all of you will participate in some way and help us to move the data quality of this homelessness data a bit further.
Now, Jeff, can you see my screen and the instructions document?
Yeah.
Okay, perfect. All right, guys. I was just explaining to you how to access the data. I think Corinne already showed most of this, but you just need to make an account on DataForGood. And once you get to the project page, you can launch the workspace here. Once you're done with everything, we would appreciate if you add insights, and you can add that by clicking this new insight button. And then
So,
just,
sorry. Hannah, you said make an account on DataForGood. I think you meant make an
account on
data.world, right?
That's too much data.
Yeah.
Yeah. Sorry, you have to make an account on data.world, and then you can access our project. And then after, you can add insights, meaning your results here. You can add, it's like a text document. You can add text, and you can add figures here. So any PNGs or JPEGs would go in here. If you have any questions, you can come to our Slack page, and the link is here. So just click on that, and you can ask us questions there. Any confusions, any more information that you need, you can get from here. If you have, in the end, some code or these recipes, kind of a record of what you've done to share, you can paste them in the insight page, or you can go ahead and request us on this email address here, and we'll give you access to our Nextcloud, and you can put all your related data there. Yeah, and these were a list of just some recommended software. So I talked about OpenDefine, but there are others that you can use depending on what your preference is. So that's about it.
Excellent. So that's a really good comprehensive overview when you put all these pieces together. Thanks everybody for joining us this evening. You have your work cut out for you for this Micro-Datathon. We'll hope you enjoy it, and please communicate with the group. Use the Slack let's kind of help to build our community and help each other with doing data for good. So with that, good evening, take care, and we'll see you at one of our future events. Bye now.